This is notes for 10.7, area of a circle and sector. All right, area of a radius is pi r squared, but I like putting down pi times r times r. And the reason why I do that is most students, when they see the square, they multiply by 2 rather than multiplying it by the number again. So if you could, write pi times r times r. All right, first problem. Find the area of the circle. So what is my radius? Oh, and it also says leave it in terms of pi. So when you do these problems, act like pi isn't there and then put it on at the end. So what's my radius? My radius is going to be 3. They show you the diameter, which is 6, but you want the radius. So 3 times pi. So 9 pi. The next one, they show you the diameter again. You want half of this. So 5.5 times 5.5 times pi. And you come out with an answer of 30.25 pi. And the next one, again, they show you the diameter. So you want just the radius. So 0.85 times 0.85 times pi. And when you multiply that out, you get 0.7225 pi. I guess I better put some labels on here. Feet squared for that one, centimeters squared for this one, and inches squared for that. Remember, it's squared because you're talking about area. Vocabulary: a sector of a circle is a region bound by the arc and of the circle of 2 radii and the arc's endpoints. So a slice of pizza on the right is a sector. Notice that it includes the crust. It is not just the pizza itself, it also includes the crust. So looking at this nice equation here, I'm going to rewrite it into the following. So theta, which is talking about the angle, times pi times the radius all over 360. All right, that is the shaded area. That's how you find the shaded area, just a part of the circle. All right, so let's take a look at the problem here. So again, I just want to find the shaded area. So again, I'll come over and write the formula. Theta times pi times r all over 360. All right, so doing this problem, theta is 72 times, they don't say leave it in terms of pi, so 3.14 times my radius, which is 20, times 20 all over 360. Putting that in the calculator, you end up with 251.2 centimeters squared. Segment of a circle. So this is a tiny little bit, and it's not connected to the center of the circle. So this was called the segment of a circle. All right, so the area of the segment of a circle is equal to the area of the sector minus the area of the triangle. And so most of you know what the area of the triangle is. Most of you would come and say area is equal to 1/2 base times height. But that's not going to help us with this triangle because we won't be able to figure out what the base of the height is, and this is on a slant, and we usually just have the degrees there. So we have to use something different. So what's the formula for the area of a circle? Theta times pi times r times all over 360. And you're going to subtract the area of the circle, so you're going to have to use side angle side. And that is 1/2 BC times the sine of A. and that'll leave us with this little bit right here. So if you drew a line that came straight across like that, excuse me, you do the whole sector and you subtract this triangle, and that would leave you with this little itty bit right here. So let's go do a problem. So my angle is, looking at the formula up here, my angle is 120. Again, it doesn't say, leave it in terms of pi, so times 3.14 times my radius, which is 24, times my radius, which is 24. I don't know whether to put the dots or put the times, right? All divided by 360. So this is my sector. I'm figuring out my sector right now. And then I'll subtract my triangle. All right, so this answer is going to be 602.9. And now I'm going to subtract my triangle. And looking at the formula for the triangle is 1/2 times my side, which is 24, times the other side, which is 24, times the sine of the degree, which is 120. And doing that, I end up with 249.4. And subtracting the 2, I will end up with 353.5 feet squared for this little section.